Hi everyone. Today we are going to discuss Jacobian of implicit function. Now you know very well what is a Jacobian. Jacobians, here you have to find the function of given function. Suppose x and y, these are the given function, and what are the implement function, and how to find the Jacobian we will see in the previous session. So let me start here. Jacobian of implicit function. So actually what is the concept of this implicit function? Now let me start here. So if I am writing now here, if u and v are the implicit functions of x and y, means what is that? These are mapped with some functions f1 and f2 such that these are the equals to 0. Means let if u and v are the functions of, or are, I am saying are implicit function of, are implicit functions of x and y mapped by f1 comma f2 such that u of xy that is equal to 0 comma v of xy that is equal to 0. Means u here 0 and v here 0. So that implies these are the functions. Means f1 of here u v x and y, that will take here 0 also, and here the function again f2 means it will contains also u comma v x comma y, this is also here 0. Then dabba uv upon dabba xy, right? Dabba uv upon dabba xy, that is equal to, that is a minus 1 whole square in bracket. So that is very important, you have to understand it here. So you have to find Jacobian of function f1 comma f2, right? And f1 f2, these are the functions of, what is that here? Dabba of xy. So that is a dabba of xy. So divided by, here also you will have to calculate here dabba f1 f2 upon uv, means dabba here f1 comma f2 upon dabba u comma v. I hope you have to understand this formula is what, right? So this is implicit function formula. If u and v are the implicit function of x and y, then you have to write the formula in this way. So this is what, this is dabba uv upon dabba xy can be written as now this in this way. So we call that is a numerator and denominator, that is we call that is a numerator upon here denominator. For simplification we have to understand it say. So these are for only two functions. Now similarly if u v w, if u comma v comma w are implicit functions of, are implicit functions of x comma y comma z mapped by f1 f2 f3. f1 is a function, next function is f2 is a function, and next function is f3, such that u of x comma y comma z that is equal to here 0, v of x comma y comma z that is also equal to 0, and w of, that is a function of x y z that is equal to also 0, and the mapping takes such a function as, that is suppose f1 of here u v w x y z, u v w x comma y comma z, that will equal to 0. Now another function I am considering here f2, that is f2 of here u v w x y z that is also equal to 0. So now same functions are same variable is there. And lastly we have to see just about third function. So what is that? This third function is f3, and f3 of here u v w x y z, same variable are here that is equal to 0. This is for three function. Then how it will be calculate dabba u v w upon dabba x y z? Now let's see. Then dabba u v w upon dabba x y z. So how it will be calculated? both are mapped with some function. So there are three variables, that's why this is minus 1 raised to bracket cube. And inside the bracket you should have to write here, that is a dabba f1 comma f2 comma f3 upon dabba xyz divided by what is that here, divided by, so this is a dabba f1 f2 f3 divided by dabba uvw, that is a numerator upon denominator here guys, numerator upon denominator. So let's see here, dabba f1 f2 and f3 divided by here dabba u, v and w. This is a Jacobian for three variables, I hope so you have to understand. And we say that is a numerator upon denominator, we say that is a numerator upon here denominator. But you know that the value is a negative is there, because a minus 1 raised to cube, that is a minus numerator upon denominator. Hence dabba u, v, w upon dabba xyz, that is equal to minus of numerator upon denominator. So you see what is a numerator and what is a denominator. It is a true for functions of several variables. So it is a true for functions of several variables, right? So I hope you have to understand this concept of implicit function. Now let me start example on implicit function. So let me start example based on Jacobian of implicit function, right? So I'm writing here example based on Jacobian of an implicit function, right? So let's see, we are going to start here. So example number first, I'm writing here example first, if u cube plus v cube, that is equal to x plus y, comma u square plus v square, that is equal to here x cube plus y cube, then show that dabba uv upon dabba xy, that is equal to here 1 by 2 into y square minus x square upon uv in bracket u minus v. We have to just show this. So focus on your question, what is given to you and what you have to solve here. Let me start solution, right? So let the implicit functions can be given as, function can be given as, so what are the implicit function you have to given in a question? So we say that is a function of u, v, w, x, y. So there is a 2 variable and 4 variables is there, function of u, v, x and y. So let me call that is function f1, and f1 is equal to, what is that here, that is a u cube plus v cube minus x and minus y, we call that is equal to here 0. And we define again f2 is defined as, that is u square plus v square minus x cube minus y cube, and that is equal to here 0. So these are the f1 and f2. Now you will have to differentiate f1 and f2 partially with respect to u and, or with respect to x, y, u, v. So I'm writing here differentiate, that is a very important step, differentiate f1 and f2 with respect to here x comma y comma u comma v. Because of that, f1 and f2, these are the functions of 4 variables partially. So we get, what we will get here, I'm writing first dabba f1 upon dabba x. What is that? Dabba f1 upon dabba x, it will get other variable keeping as a constant, it will get clearly -1. Next dabba f1 upon dabba y, so it will get here again -1. Next one is here Dabba f1 upon dabba u, keeping other variable as a constant, so therefore it will becomes that is a 3u square. Dabba f1 upon dabba v, this will becomes plus that is a 3v square, 3v square. I hope you have to understand this. Also similarly, dabba f2 upon dabba y, dabba f2 upon dabba y, or I'm saying first x, so it will takes the values is here, that is a minus of 3x square, keeping other variable as constant. Dabba f2 of dabba y, differentiation of f2 with respect to y partially, it will get minus 3y square. Next, dabba f2 upon dabba u, is differentiation of f2 with respect to u partially, it will get 2u, keeping other variable as constant. And here dabba f2 upon dabba v, so what you will get here, that is only you say, or you have to concentrate on f2 with respect to v, keeping other variable as constant. This is a 2v, this is a 2v. I hope so you have to understand this, what is the partial derivatives of f1 and f2. Now we know that Jacobian of implicit function can be given as, let we have Jacobian of implicit function given as, let me write in next slide, Jacobian of implicit function given as, so let me write here, that is a dabba uv upon xy, dabba uv upon dabba xy, this can be equal to, this is a minus 1 bracket square into numerator upon denominator. But what is the numerator and what is the denominator? Numerator is, what is that here, dabba f1 comma f2 upon dabba uv, right, dabba u comma v. So this is nothing but here with respect to x and with respect to y, and divided by, I am writing in a denominator now, what is that here, dabba f1 comma f2 with respect to partially we are to taking dabba with respect to u and v. So we called that is a numerator and denominator, guys, numerator and denominator. So we called, for references, this is equation number 2, this is equation number 2, and equation number 1 is here. So these total values we call, that is equation number 1. So let's see. So we have to use these 4 values or use these 8 values for finding Jacobian. Now let's see what is a numerator, guys. What is a numerator? I am calculating first what is a numerator. So numerator, that is equal to, that is a dabba f1 comma f2 with respect to here dabba xy, right, dabba xy, and this is equal to, what is that, it is a determinant of, that is a dabba f1 by dabba x, dabba f1 by dabba y, dabba f2 by dabba x, and dabba f2 by dabba y. We have to just simplify here. So what we have to getting here? So here we have to getting 1 minus 1, right, 1 and minus 1, and next second column minus 3x square minus 3y square, minus 3x square minus 3y square. So it will takes the values is here. So what will, after simplifying this, that is a 3y square, right, 3y square minus 3y square, this minus and minus there will be plus, and this is a minus is again 3x square, right. If you have to simplifying this, that is a plus and minus is here. So what is that, after taking cross multiplication, that is a minus 3y square, this is value for minus 3y square minus 3x square, right, this is a value for that Jacobian, right. So numerator it becomes, so actually this value is a minus 1, this value is a minus 1, and this minus and minus there will be plus, this minus minus again plus, and then minus is there. So therefore this is equal to, this is 3 in bracket, what is that, y square minus x square, 3 in bracket y square minus x square. So we get clearly numerator is equal to 3 in bracket y square minus x square, right. So we call this is equation number 3. Now denominator as, also taking a denominator equals to, what is that here, dabba f1 f2 upon dabba u comma v. So this is a 2 by 2 determinant, guys. What is that here, dabba f1 upon dabba u, dabba f1 upon dabba v. So I'm writing very clearly, guys, dabba f1 upon here dabba u, dabba f1 upon here dabba v. Similarly in second row, dabba f2 upon dabba u, and here dabba f2 upon dabba v. So this is 2 by 2 determinant you will have to solve here. So what are the values of this numerator and denominator? So denominator values you have to put in here. That is a 3u square, dabba f1 by dabba u, that is a 3u square. Next it is a 3v square. Next it is a 2u and it is a 2v. I hope so you have to understand this. So this is equal to, guys, that is a 6u square v minus 6uv square, right? So therefore the denominator becomes, that is a 6 in bracket u square v minus v square u, right? And this is also equal to, again I am taking here u and v are common on this bracket, so therefore 6uv in bracket u minus v. So that is equation number 4. So from equation 3 and 4, therefore from equations 3 and 4, equation 2 becomes, what will get the equation 2? Equation 2 is that, what is that here, that is a dabba uv upon dabba xy, right? So that is equal to dabba uv upon dabba xy, that is equal to, that is a numerator upon denominator, means minus 1 whole square numerator upon denominator. So minus 1 whole square is a 1, numerator is, what is that here, 3 in bracket y square minus x square upon here 6uv in bracket u minus v. So it will get clearly, Jacobian of uv with respect to here Jacobian of xy, that is equal to, this is a 1 divided by 2 in bracket, or that is a y square minus here x square divided by here uv in bracket u minus v, and this is your answer, this is your proof, hence the proof. I hope you have to understand this, what is the proof. Understood this? Now let me discuss example number 2. Example 2 given to you. If x square plus y square plus u square, if x square plus y square plus u square minus v square equals to here 0, and uv plus xy that is equal to 0, then prove that dabba u comma v upon dabba xy that is equal to here x square minus y square upon u square plus v square. So let's see how it will be solved. So solution is there. Let implicit functions are f1. What is f1? You have to given is here, f1 is equal to here, simply you observe the first function, that is x square plus y square plus u square minus v square, and f2 is equal to, this is a uv plus xy, this is functions of uvxy, this is functions of uvxy, we call that is equal to 0. Now we know the Jacobian of implicit function. So here in a solution, let you have to define an implicit function. An implicit function is given x square plus y square plus u square minus v square, and second implicit function uv plus xy equal to 0. Now let me start. What is the definition of a implicit function actually? So you know very well the Jacobian of implicit function is given as, so we have Jacobian of implicit function as, so it is the dabba uv upon dabba xy, that is equal to minus 1 whole square in bracket, what is that here, dabba f1 f2 upon dabba xy divided by dabba f1 f2 upon dabba xy. So now upon dabba uv, this is a definition. We called numerator and denominator is there. So minus 1 bracket square, that is nothing but it is a plus 1. So this is equal to numerator and denominator. For consideration here to here 1. So now let, what is a numerator? I am calculating separately what is a numerator. Numerator is dabba f1 f2, right, upon dabba xy. So this is equal to, this is the determinant of here dabba f1 upon dabba x, dabba f1 upon here dabba y, dabba f2 upon dabba x, and dabba f2 upon dabba y. So therefore this is equal to, so what we will get here very clearly. So this is a determinant of, I am writing the differentiation, partial differentiation directly in this determinant. So dabba f1 by dabba x, it will get, you have to observe f1 function, it will get 2x. Dabba f1 by dabba y, it is a 2y. Dabba here f2 by dabba x, it is a clearly y is there, and here that is x. And calculating this, what we will get here, there is a 2 in bracket x square minus y square, 2 in bracket x square minus y square. So therefore numerator becomes, that is a 2 in bracket x square minus y square. I hope so you have to understand this. That is a, for consideration we have to call, that is equation number 2. Now we have to calculate the denominator. Therefore denominator, as this is nothing but that is dabba f1 dabba f2 divided by dabba u comma v. This is Jacobian of f1 f2 divided by v. So I am writing the values of this dabba f1 by dabba u, dabba f1 by dabba v, dabba f2 by dabba u, and here dabba f2 by dabba v. So right, so therefore this is equal to, we have to put up the values directly in this Jacobian. So it will get after simplification, you will have to getting the values of with respect to u and v is there. So what is a dabba f1 by dabba u, that is 2u. I am writing here 2u, right? So that is equal to dabba f1 by dabba v, that is equal to minus 2v, that is equal to minus 2v. Then dabba f2 by dabba u, that is v is there, and here is a u simply. So therefore you have to just calculate it. So therefore this denominator is equal to 2u into u, that is a 2u square, and minus that is a plus, that is a 2v square. So clearly 2 is a common, and here u square plus v square. So therefore this denominator equal to 2 in bracket u square plus v square. So for consideration this is equation number 3. So from equation 2 and 3, equation 1 becomes, so what is equation 1? That is a dabba of here uv with respect to xy, that will becomes, that is a minus 1 raised to, means here numerator upon denominator. So what is the numerator here? Numerator is a 2 in bracket x square minus y square, and the denominator becomes 2 in bracket u square plus v square. So therefore 2 to get cancelled here, and it will get the value of here x square minus y square divided by here u square plus v square, x square minus y square divided by u square plus v square. This is value. I hope so you will have to getting here the final step, dabba uv upon here dabba xy, this is equal to here x square minus y square upon u square plus v square. I hope so you have to understand this now very well. You have to understand this very well. So this is a proof. This is a proof, right? So in this session we discussed what is implicit function and how to solve implicit function by using the definition of implicit function is there. Now it is sufficient for today. Thank you.